Now formation of calcium chloride, CaCl2, Ca having configuration 2882 loses 2 of its electron and become positively charged having configuration 2, 8 and 8. On the other hand, chlorine having configuration 2, 8, 7 accept 1 electron and becomes negatively charged ion having configuration 2, 8, 8. Now, since chlorine is accept 1 electron and calcium donate 2 electron, so there is a requirement of 2 chlorine atoms so that each chlorine can accept 1 electron of calcium. So in this way we require 2 calcium atoms. Now 2 Cl, 2 electrons and 2 Cl negative. Now on the both sides there are electrons, we can cancel it like this, and the overall reaction is Ca plus 2Cl, Ca2 plus 2 Cl minus, 2 negative charge, 2 positive charge. So this will result in the formation of CaCl2. This is the equation method, and in electron dot method, this is the calcium having 2 electron in its outermost shell. This is the first chlorine and this one is the second. Both will have 7 electron in their outermost shell, 7 electrons. Similarly, this chlorine also will have 7 electron. Now calcium donate 1 of its electron to the chlorine of its right hand side and 1 electron to the chlorine of right hand side. This will result in the formation of Ca2 plus and Cl along with the electrons of chlorine and calcium. This will have single negative charge, and this will also have single negative charge. Now we can show all of them like this. Negative charge, negative charge. So there will exist a force of attraction between these two and results in the formation of CaCl2. In atomic dot structure, this is the calcium nucleus, 2 electron in first shell, 8 electron in second shell, eight electron in third shell, and 2 electron in its outermost shell. The chlorine atom having 2 electrons in its first shell, 8 in second, and 7 in third shell. This is the second chlorine nucleus. This is the first cell having 2 electrons, second shell, eight electrons, and third shell with 7 electrons. Now this electron of calcium will transfer to this chlorine and this one transfer to another chlorine. Here till then the configuration is 2, 8, 8, 2 and 2, 8, 7. Now this results in the formation of charged species, that is the cation and anion. Now this calcium already have loosed its 2 electron of outermost shell, so that shell will be absent. This will acquire 2 positive charge, and on the other hand each chlorine will acquire 1 negative charge after accepting 1 electron from the calcium. Since it accepts 1 electron, this will have 1 negative charge. Here the configuration of calcium is 2, 8 and 8, and of chlorine is 2, 8 and 8. Similarly, another chlorine that will also have 8 electron after accepting 1 electron from the calcium, having 1 negative charge, configuration 2, 8 and 8. Now chlorine are negatively charged and calcium is positively charged, so there will exist a force of attraction between these two. There will be a force of attraction between these two. So this will result in the formation of CaCl2. Now take another example of magnesium oxide. In which configuration of magnesium is 2, 8 and 2. Magnesium will become 2 positive charge after losing 2 of its electron and become cation. The configuration of oxygen 2 and 6, this requires 2 electrons to become stable. So oxygen accept 2 electron and have the configuration 2 and 8 with 2 negative charge. Now overall reaction Mg plus O, Mg 2 plus and O 2 minus. So there will exist a force of attraction and this will result in the formation of MgO. In electron dot structure magnesium, it has 2 electrons in its outermost shell and oxygen has 6 electrons in its outermost shell. Now this electron get transferred to the oxygen and this will also transfer to this oxygen. This will result in the formation of Mg2 plus and oxygen 2 minus with the 8 electron. Now this is the force of attraction between the oppositely charged ions, and the compound is magnesium oxide. Now another type of bond is covalent bond, in which sharing of electrons take place. Remember, both the combining species, whether they are homoatomic or heteroatomic, should be electron deficient. Now let's take example of homoatomic molecules. The first one is H2 hydrogen. Hydrogen having one electron in its outermost shell, that is K shell will have only one electron, while this requires two electrons to become stable. So there is a deficiency of one electron in hydrogen. Since there are two atoms of hydrogen, both will have deficiency of an electron. Suppose this is the first hydrogen having one electron, and this electron belongs to the another one. And if the first hydrogen shares electron of second hydrogen, so this will have two electron in its outermost shell. And similarly, on the other hand, second hydrogen also shares electron of first hydrogen to become stable. Now both hydrogen have two electrons after sharing. Since there is a sharing of only one electron between these two, so there will exist only single bond between hydrogen, and this will result in the formation of H2 molecule. Let's take another example of oxygen. Oxygen, it has six electrons in L shell. This requires two electrons to become stable. So this is the first oxygen, 1, 2, 3, 4, 5, 6 of its electrons, and another oxygen, 2 electrons, 3, 4, 5, 6. If first electron shares to these electrons of second oxygen, so this will become stable. Similarly, second oxygen also shares two electrons of first oxygen to complete its octet and become stable. Now both the oxygen shares their two electrons. So there will exist two bonds between oxygen, and this will result in the formation of oxygen molecule. Now third example is of nitrogen. Nitrogen, atomic number 7, distribution of electron, K shell will have 2 electron and L shell will have 5 electron. Now L shell requires 3 more electron to become stable. This is the nitrogen first, having 5 electron of valence shell, and this is the second nitrogen having 5 electrons. Now if first nitrogen shares 3 electrons of second nitrogen, then first will be stable, and on the other hand second nitrogen will share 3 electrons of first nitrogen and will become stable. Now there are sharing of 3 electrons between these two nitrogens, so there will exist triple bond between nitrogen, and this will result in the formation of N2 molecule. The next is heteroatomic. molecules. The word hetero stands for different. In other words, we can say not same. First example, formation of methane, that is CH4. Now carbon and hydrogen, they are totally different elements. Carbon atomic number 6 have configuration 2 and 4. So carbon requires 4 electron to become stable. On the hydrogen, it has only 1 electron, and this requires 1 electron to become stable. So this is the carbon having 4 electron of its valence shell. This is the first hydrogen with its electron. This is the second hydrogen with its electron, third, and this one is the fourth. Now this hydrogen can share this electron of carbon to complete its duplet. Similarly, second one, third one, and fourth one. We can see that duplet of all hydrogen are completed. Now carbon has 4 its electron. It can share 4 electrons of different hydrogen atoms to become stable, and in this way it will complete its octet. Now 1, 2, 3, 4, 5, 6, 7, 8 electron. Since there is a sharing of 1 electron between carbon and each hydrogen, so there will exist single bond. And results in the formation of covalent compound methane.